My name is Jason Price. I'm on the Gold team. Today we're going to talk about proportional controller design and some results. Fellow teammates are Jeremy, Jared, and Simon. We're going to look at the FOPDT parameters that we used for the proportional experiments. Look at some root locus results that we got from using those values. We're going to talk about the proportional controller gain, the modeling, and the experimental results, and look at discussion. For the voting modeling, we found that our gain for our system, this is an average value, all three. We had three ranges, or actually four ranges. Our entire space height operating curve was divided into three sections, and then we did a fourth, which actually covered the entire range. On a whole, the values closely followed each other, so we came up with an average value of 1.3 volts per percent for the gain, 0.06 seconds for dead time, and a time constant of 0.09 seconds.
Did you show the SSOC?
Did not show the SSOC.
You did not show the SSOC?
I mean, yes, you missed it.
Could you go back and let me see it again?
Well, I just already deleted it, so we're just moving on.
You didn't delete it?
No, I didn't put it in
Go back.
there. It's
not in there?
I promise it's not in there.
It's not. He doesn't have his SSOC in there, team. Do you remember his SSOC?
I remember it fondly.
Straight as a Y, straight as an arrow, just linear, all right?
Absolutely.
All right, go.
You're trying to be serious.
All right, let's say that must be boring. Boring.
That's why I left it out.
Yeah.
Here we have the root locus results. For the critically damped, we found the Kc value to be 0.22% per volt, 500th decay 0.68% per volt, Kc of the 1/10 decay 1.7, quarter decay 2.2, and the ultimate to be 3.4. And this is using the values that the model had in Excel to produce the root locus. The model-only, the proportional controller modeling results were critically damped. There was no overshoot, obviously. The Kc value was 0.4. Settling time about 0.2 seconds. And the offset was about 4.5 volts. 1/10 decay, Kc was 1.7% per volt. Decay ratio of 0.1. Frequency roughly 3 hertz. Settling time 0.5 seconds. And an offset of 2 volts. Got a little closer. Quarter decay. Overshot about 14%. Decay ratio 0.25, frequency 5 hertz. Settling time 0.8 seconds, and the offset 1.7 volts. Kc was 2.2. Then we get to the ultimate controller gain modeling. Kc value about 3.4% to get this type of graph. Decay ratio 1, 8 hertz frequency roughly. Yes. Never settles, and the offset. Kind of assuming that it's oscillating there around this point here. So in the midline of the oscillations, offset about 1, if we averaged it out. So here's a table that shows our results. The initial set point for the entire, for my section that I did was for the entire range. The set point was right in the middle of our range, came out to be 84. The step for that particular region was going to be -7 volts. The KCU for the critically damped was 0.4, 1/10 decay was 1.7, 2.2 for the quarter decay, and ultimate 3.4. I won't bore you with all of them, but you'll notice that even over the course, our state operating curve, as Dr. Henry mentioned, was fairly linear. I don't know that magically corresponds with it, but all of our values followed each other very closely, except for the one down here. But that was modeling. And here's a graphical form so you can get a better idea. The lower range is a little bit lower as you go up our state operating curve. The values tend to grow just a little bit, but the critical decay values, the 1/10, the quarter, and the ultimate, they all follow very closely across the different regions. Again, this was for the modeling. Now we'll start looking at the experimental results for critically damped. Values only 0.22%, per volt, which I think was actually closer to the other one, settling time 0.2 seconds, and an offset of 5 volts. This is where it starts to deviate from the modeling substantially. The Kc value for this is only 0.3% per volt, and the offset's still around the 5 volt range. 0.4% here for quarter decay, 4-volt offset. Ultimate controller gain, as we see, it doesn't settle down at this point. KC value only 0.9, substantially different from the modeling. See a summary table in a minute to describe it a little bit better. So here's a summary of the results for the critical. As you can see, the values do follow fairly closely, substantially less than what we had before. Here's the graphical version of the same data. You see the ultimate gains very high across the board. Bigger jump in the data between the quarter decay and the ultimate and the experimental results as opposed to the modeling. Now what we had done here is we're comparing the root locus results, the modeling results, and the experimental results. The root locus and the model, both based on equations in Excel, they follow each other fairly closely. However, experimentally, when we actually run the system and get values significantly lower than any of the either of the two modeling options. So in conclusion, the model versus design is very different, and unfortunately with a proportional controller, the offset is always present, so we can get rid of it. That's it.